Well, hi and welcome to my shop, and thanks for joining me today. Today is October 27th. Holy smokes. So, I posted a very long video yesterday. I feel a little uncomfortable when I post them that long, because that's quite a demand to watch something like that. But it is the story. I am trying to cover the story, and if I chop it up, the story doesn't make a lot of sense. Not that it made a lot of sense anyway yesterday. But yesterday evening, with the help of someone who has been helping me a bit in the background, I made a big discovery about this radio and its crazy band lights. The band lights that are not in the right order. I think I'd mentioned I studied the wiring here, and I just can't find any kind of reason for the band lights to be wrong. Well, it turns out the band lights are perfectly correct. The lights go in the right order. What's not in the right order is the dial glass. Can you believe it? The dial glass is incorrect. Well, you say, well, how can that possibly be? Because this is really 5 pieces of separate glass. And they've been assembled using these metal strips here, which connect it all together, and then they're very tightly held in a frame out here. And then it kind of looks like one piece of glass. It's nicely straight. You'd never know. The mirror effect is really nice on it. But in fact it is. It's different sections. Somebody assembled this wrong. This band should be up here, and this one should be down here. And likewise, these two should be reversed. The broadcast band in the middle, well, you can't go wrong with that. So that just blew my head off. I never imagined for a moment that it could be wrong. And I'm going to stop and show you how I know that it's wrong. So I was looking at this diagram and studying the buttons as they're shown here to look at the order of the bands, and this is certainly how the bands rotate. That's broadcast, the lowest frequency band, and the next lowest, and this is the highest up here. These are the two that aren't working. What I didn't manage to do was notice this, the glass itself. There you can see the standard broadcast is in the middle, but on my radio, this band is the top band. Not 6 megahertz, 15 megahertz. So here the glass is shown correctly. So it would basically, the lights would go from this band and then they'd work their way down one band at a time as you rotate the dial, just as they do. Oh my gosh, somehow this glass got assembled wrong on this radio. How can that happen? I guess there's only a couple of ways it can happen. One is it was done wrong in the factory. That's hard to believe, but that's possible, I guess. Came out of the factory wrong. When I look at the rubber mounts and things like that, to me it all looks undisturbed. It all just looks like no one's ever done anything. But another possibility is somebody disassembled this somewhere along the line. Why somebody would do that, I have no idea. And then when they reassembled it, they reassembled it wrong. I mean, that's just about as hard to believe too. No matter how you look at it, this is a really surprising thing to be wrong in a radio. And since most radios have one solid piece of glass, I couldn't even imagine it being wrong. My paradigm was otherwise. So the solution here, now that I understand what has happened, is simply to rewire the lights so they do go in the order of the band glass. So that's number one. But there's a number two. Another thing that came clear to me last night for the first time, and that is how this switch is depicted in the switch, how it's depicted on the schematic. So we're going to take a look at that. And I haven't taken the time to really study things now that I understand how this switch operates on the schematic. So I'm going to just show you what I found, and then I'm going to study it on my own, see if I can't gain any insights into the problem with this radio. The two higher band, the oscillator doesn't work on them. The hint I'm going on is that there's two bands involved in this, So something must be common about the two bands. Now, the one thing that is common, I think I've mentioned this before, is they're the highest frequency bands. So if an oscillator is struggling, its struggle gets worse as you go up in frequency. So that's the only association I know of right now with these two bands, is they just happen to be the higher frequency bands. But now that I understand the switch, which I'm going to show you, maybe I can make some kind of breakthrough here. So here's the switch. And, you know, in the back of my mind, maybe I figured this out a year ago when I was looking at this radio, and it just simply melted out of my head until now. But now I can see quite clearly how it works. So this piece on the schematic slides upwards as you advance the band control. The diagram is shown on the broadcast band. So the way these things are connected up is for broadcast band operation. And we're going to study that a little bit here. So if you move this up one snap, this line will disengage here and engage here. And if you go another snap, this line and all these are moving up. So this line would be here, engaging this coil. Meanwhile, this part of the switch is moving upwards. At broadcast band, it's connected here. That's how the connection is made out to the grid through there. If we snap the switch forward, this piece is now contacting here, and this piece is now contacting here. So there's always something contacting here. I snap the switch once forward, now you've included this. You see all these arrows here? So as the switch is advanced forward, you pick up more and more of these guys. And what are these guys? These are those very special capacitors, I'm pretty sure. A little hard to read the schematic here. Maybe if we zoom in just a wee bit, you can read it better. So I believe that says 100 picofarads. I believe this says 100 and something 0.5 picofarads. I believe this says 56.5 picofarads. So, you know, in engineering writing, when you write a number with precision like that, you're communicating the fact that the value must be precise. If this were a 0, it should be written 56.0 to convey the same level of precision. That's what's got me hesitant in replacing all these capacitors here, because the precise value and the fact that I did replace one, I replaced this one. So 110 picofarad. Boy, that looks like 119 there. 110, I believe it is, though. And I've replaced it with 110 picofarad brand new capacitor. Took this one out, found out there's really nothing wrong with it at all. So I suspect there's nothing wrong with any of these. That's kind of where that stands. So you're selecting coils. Well, not always a coil. Selecting a capacitor here, which is kind of interesting. Otherwise, as this goes up, it's selecting this coil, and finally that coil. Meanwhile, you're adding on more and more capacitance. So while we're looking at it, this is what I would call a tickler coil. I don't know if that's really the proper thing to call it. It's wound tightly or closely with this coil. I think I showed you that. It has the two wires coming up from the tube going to it, the red wire, and the other one is some other color, blue or something. So to me, what this is saying is, in order to make this set oscillate on the highest frequency, you need this coil in place to help with the feedback, help get the oscillation going. Is that really true? I don't know for sure what they're doing with this coil. Maybe it's to prevent oscillations, spurious oscillations. I just don't think so, though. They don't have a similar coil on these others. So I think that's a hint. And all these radios, as you get up in the higher frequencies, they struggle a bit. It's tough to make oscillators oscillate at these high frequencies, which seem like very low frequencies by today's standard, and of course they are. They're puny in comparison to what's going on in our cell phones and things like that. Shockingly high frequencies, in fact. But back in the day, when you get up in these higher frequencies, tube interelectrode capacitance would begin to interfere with the operation of everything. Of course, that was solved in the tube world by the introduction of the screen grid here. So, this radio seems to work fine on broadcast. If we picture this going up one snap, it works fine on the next band. That's the 6 megahertz band. If you snap it one more, it seems to work fine on this band, although it might be just a little weak. I'm not sure about that. Snapped it up 1, 2 settings at that point, so you're up to including this capacitor. Oh, I see something coming. I can see something coming. We snap this, the next band up, now it stops working. And at that point, we have snapped in this capacitor. Likewise, when we go to the next band, the last band, the highest band, which also isn't working, even though the switch now, which has 5 arrows, but only 4 pieces, 4 capacitors here, or four contacts, the last arrow will be pointing in space out here. It's not connecting to anything. But this guy is still connected. So the last 2 bands connect this capacitor. That's what they have in common. That's what I should have figured out how many hours ago? many hours ago. This capacitor is the guy. We gotta find him. What is it? So this is 6, 7, I think that's 5, C5. Looks like 100. Well, I could easily replace a 100. C5. Okay, so let's go find that on the diagram, the layout diagram. Here we are. C5 on the layout diagram. Somewhere in here. C16, C8. That looks like 52 to me. C6, C5. There it is. Well, that's not too hard to get to. So in this radio, I've replaced this one already. There's the 110. Yeah, it does say 100. Excellent. See, the one in here says 96.5. Well, I don't have a 96.5 capacitor, although I could probably botch one up. This guy is the problem. That's my theory now. 100 picofarads. So we'll go on the radio, find out what's up with this capacitor. Wow, it's amazing what letting a little time go by and a little bit of time. So here's the one I replaced. This is the next one over. The next one over is back in here. Well, what's the matter with it? We know in the lower bands that capacitor is just going absolutely nowhere. So I'm going to put the tester on it. You really need a drum roll here. We're going to make sure it's not on that band. This is usually the point where the theory just melts down into nothingness, but here we go. You know, like a lot of things, when you finally find them, you say, oh my God, why was that so tough? Why didn't I? 104 picofarads, no loss. It's really on the money. That's really the 104. The extra 4 is probably from the fact that it's in the circuit and there's just stuff all around here adding a couple of picofarads to the measurement. Okay, so we just flush that guy down the drain, but wait a minute, it may not be the capacitor, it may be the switch contact. Oh, if it turns out to be a switch contact, yeah. I spent a long time examining the switch contact, but not particularly focused on any one thing. So I'm going to try to get us a good view of this. Maybe if I get the camera coming up from below here. Let me set that up. Okay, so here's our first look at it. Now, that is definitely the capacitor I tested. The end of it there, you can see. And it measured right around the expected value of 100. So pretty doubtful I have the wrong capacitor. And I'm saying this for some good reasons. I'm just changing the focus here so we can kind of look up and down it. So I'm going to rotate the switch and just watch. See the two gripping fingers there? You can watch them come apart as the switch goes in. Now, this is broadcast band. Let me go back. This is broadcast. Okay, this is the first shortwave band. It's 3 and 4 that this should be engaged with. Did you see it move there? It's getting engaged here on band. This would be the second shortwave band. The third shortwave band. Now I can see the switch just beyond it is engaged. Let me come back. Looks like the switch in question has stayed engaged with something. Can't quite see. Now we go one more snap. That's the end of the road. So that's the top band. Coming back. It doesn't quite make sense to me. So it certainly looks like it's engaging with that. What's on the other side of the switch? So there are no. It's a one-sided. Well, it's not really a one-sided switch. On the other side of the switch is the coil selector. On the side we're looking at is the capacitor selector. What? So on the switch beyond, the little switch fingers beyond there, is there anything hooked up to it? Is there any connection made to it? Let me see if I can get a little better lighting on this. Oh yeah. Yeah. Let's just blast in some light. Okay, I'll operate the switch again. So I'm looking for the finger that should be going into those switch. There it is. Now I see it. Going in. I think it's coming out, but I need to look at the actual the rotating part of the switch. So if you look on the left of the switch in question, it's a little out of focus, but you can see this is broadcast. I go one step, that's engaged. Right there, you can see the piece. You can see the piece coming along. It's a continuous bar. So this is the collector collecting the capacitors. So it's collected that first one. It's collected the next one. you can see the switch has traveled beyond the other grip, the one to the right on your screen, just as it would show in the diagram. And pretend that sliding part of the arrows, they're not individual arrows, it's a continuous bar. It's just so dirty it's not making contact. Could it be that simple? And the one that was giving me trouble, or I had theorized, this last one. Maybe I got it wrong somehow. And take a look at some of the soldering in there. Let me see if I can push on a wire. I think this could be the problem here. Let me just see if I can sharpen the focus a wee bit. No, not really. Tricky to look at. Let me wiggle the camera. Maybe it'll make it more apparent what's going on. Like, it looks like there's two. Wow, what does it look like? I have to move the light here to get my poker in there. So it's pretty clear where the capacitor is connected. What's going on? When I stick the tool in, I block the light. I can't see with my own eyeballs. I think it's right in here. No. Then it's right in here. Yeah, so the camera view, it can be very misleading. Now we can see it a little more clearly. There's a separate thing there. Let me focus a bit. So we have one capacitor connected, as we would expect, in front of my rod there. And then behind it is the other one. The other one. Let me look. Okay, the other one. But I got the correct reading when I tested that one. Or did I actually hook my meter up to the wrong one? I'm going to use the camera shot here and try to fish in. I don't think it's visible. Oh yeah, it is visible. Okay, so this is the other capacitor. The one that appears to be the last one, the one I should really be testing. Okay, and I'm going to leave the camera like that, and you're just going to have to listen to me when I do the test here. Let me just get the other lead on the ground. The camera's going to fall out now. It already fell out. Okay, it's falling out. Shorted capacitor. Okay, let me make sure the switch is off that band. Okay, repeat. Oh, there it is, 115. Wow, I'm a little confused there. I thought this would be the 100. Hard to read. So the capacitor is good. 115 is a little out, but you wouldn't think that would prevent the oscillator from doing its thing. Here, let me get this instrument out of here. Okay, good capacitors. It's got to be switch contacts. No, it can't be that simple. Okay, so I have some good stuff here. Deoxit. I know people love this stuff. Man alive, I spray this stuff in there and then the radio starts working. I better go back and delete a whole bunch of videos. Boy, oh boy. Okay. I know exactly where to spray it, though. Two-hander. I'm almost afraid to test the radio because of the I shouldn't feel embarrassed. I would be embarrassed to walk away and never find this problem. Now that would be embarrassing. Of course, you wouldn't know it. But the giving up part, yeah, I don't want to give up. Especially such a nice old radio. This one, the owner of this radio's been in his family forever. So, you know, it's got, oh heavens, there goes my camera. It's got some important value that way. Well, all we're left with now is testing it out. Do you think that did anything to it? Well, I got the spray stuff here. Oh, stuff's going everywhere. Really made any difference? Let's find out. This is the I don't know what it is. This is the antenna. This one's the SDR. Let's get it out of there. This is my outdoor antenna. We'll try it here. See if that cleaned things up or not. Okay, are we ready? Drum roll, please. Starting on the broadcast band, volume down. Everything is safe and ready. Nicely drained capacitors this morning. Charging up. Just to let you see. See, the band light is, it's a little hard to see in the camera. It's highlighting the center band, the broadcast band. Why am I showing you that? Something to do while it's warming up. There we are. So that rumbly sound is a typical interference sound I get in my shop. So we're working there. Don't worry about actually picking any stations up. Next band. 6 megahertz, we shouldn't be picking anything up here, but pretty obviously it's doing something. Next band. You notice the noise didn't change at all? This appears to be dead now. Can't be dead. My antenna didn't make a connection. That's what I think is happening here. I get right in the back of the radio. If the antenna wire comes into the back here somewhere, then it rises up into these coils. I can't find it. Okay. Settle down, Jim. You're getting a little overly excited. If you get into a plane and the pilot comes out and he's really excited, he goes, I'm really looking forward to flying this plane. Maybe I better get on another plane. She's dead. Is that really the antenna? Did I make a mistake? Yeah. Oh, it's pulled out. I've stepped on it and disconnected it. Okay, let me just plug it back in. Okay. Ah, this should sound better. Ah, that's a little better. Okay. That's on the 9 megahertz band. Okay, next band. So this is the first dead one. It's up really high. Nada. Nada, nada, nada. But if it's a switch, okay, turn this down before we get our ears blown off. A little bit of scrapey sound. Oh, holy smokes. What was that? Top band. I don't know what that noise was. Something interesting. $19 megahertz. Nope. Volume, volume, volume. Big pop there. 25. Nothing, nothing, nothing. 31. Working. Okay, switch didn't seem to do it. Boy, see, I got pretty excited. Sorry folks, we won't be flying this afternoon. Pilot's not sure how the switches work in the engine, in the cockpit. Okay, I'm going to stop and just calm down and think a little bit here. I really did get a little bit too excited. So I think what I need is some direct proof that the switch is making contact before I walk away from the switch being part of the problem. So we know in the schematic it has that line with the arrows on it, and we know the lower longer line is the selector of the coils, and we know that's on the back side of this switch. They're all connected together as one sliding member on the diagram. It's actually a rotating piece. Means if I connect to the coil that is selected, I am also connecting to that sliding pad, the sliding switch for the capacitors. So that means I should be able to ohm out the connection onto these leads of the capacitors. Advance the switch, ohm it out, advance and ohm it out. Ohm it out. That's not even English, is it? It's like amping up your motor. Amped up. So guys used to come in and check your furnace. The furnace belts wear down, and the ratio of the furnace motor and the pulley on your blower is varying over time. So to make sure the motor is doing everything it can, you put an ammeter on the motor lead and read the current. And they know it's a 10 amp motor, and they see only 3 amps. They know the motor is not working as hard as it could. And alter the belt arrangement and thereby amp up the motor. Did you know that's where that comes from? Amp up the motor. Okay, I'm all amped up. Time for coffee, and then I'll set up this next test. Okay, I got another angle on the switch. So, can I get in there and point at something? So I'm able to orient myself, but a little tough for you as a viewer, perhaps. The radio's in broadcast mode. So this terminal up here, which is out of focus, is the one that's connected. Broadcast coil. Can you see the finger sliding? You can see the switch grabbing it for this one. This one goes to a variable capacitor, just like on the schematic for the second band. You can see we're selecting the third, which is the 31 meter band. This one's working. Now we're selecting the fourth non-working band and the highest non-working band. You can see the switch is certainly going in and contacting. So I was wrong about selecting the coils on the back side of the switch. It's on the same side, just the other half. If you notice, there's a fair bit of play in the switch here. That's because we're in effect on the end of a long metal shaft, which is only really supported right at the front of the radio, and that's like 8-10 inches away. So there's some play in here. Now we look at the capacitor selections. So we're selecting in behind this wire. That's this wire. In behind the wire is the first capacitor. That's broadcast band. Then we go maybe I'm wrong. This first one is here. This is the first one. Yeah, it's very hard to see behind the wire, but selecting the second one and adding it in. Third one, adding that in. Fourth one. And the fifth one doesn't add one in. How does that work? Must be just based on the coil at that point, variations in the coils to achieve the different band. Physically, it all looks pretty darn good. You know, it's such an old radio. You know, how many times can you rotate the switch before you wear it out? I'm going to wear it out trying to fix it. Still need positive evidence that it's working. So basically, if I can get on, you can see the fluid still flowing around on it. If I can get on this one down here, which one's this? This is, let me just identify it this way. Do you hear my stomach rumbling there? Okay, so this one, so that's attached to the capacitor that I changed. This is the way out to the grid of the oscillator tube on this guy. So this guy's always connected. Is he? Is he always connected? There seems to be some extra dirt coming in right there. Doesn't seem to be running on dirt there. You know, how can you tell for sure? This is always in the jaws. But the clean area seems to change right here, because there's numerous fingers cleaning that off. When you get to here, there's just this last finger cleaning that, and you can see the where it's cleaned it. Just from friction. Hard to believe it's not making a connection, but you know what? I can go on that easily and then test back each of these capacitor connections. There should be a short. That's the test. So if I leave it in the high band position, all capacitors are in, all should see a short to that first capacitor. That's the test. That's the test. That'll prove things. That'll prove everything. That's good. I like that test. Okay, how are we going to do this with my ohmmeter? So I'm going to connect my ohmmeter now. Come around here. take the camera out of there. So this is the lead to the tube grid through this replace capacitor. And it's on my meter here. The other lead I want to put on a clip lead. First thing we're going to do is check the clip leads here. So I clip it on the same, just hold it on the same wire and watch the meter go to 0. Good. Now, one by one. You know what? It's easier to do it with the probe. I don't want a clip lead. One by one. There's one. There's a 0. Number 2 is a little hard to get to. Kind of feel for it up in here. There's a 0. Number 3. There's a 0. And is this number 4? There's a 0 there anyway. That's it. Let's prove this out by opening the switch. Okay, so see a 0 there. Should see it. Should disappear. Should disappear. Okay, wait a minute. No, I'm on the wrong thing here. I think this is actually a ground point. I'm not sure what I'm doing. Let's see if these ones don't open the way they're supposed to. Okay, first capacitor. Getting there. Numbers jumping around. There. Next capacitor should be open. Shorted. Oops, that didn't work. Short and open. Yeah, okay. And the next one. Open and short. Yep. What did I do here? I did 1, 2, 3. There's 4. 4. Yeah, so now I see the switch on the back side here is affecting the cathode connection from the tube. This yellow wire coming up, you can't really see it, coming up here and connect down this side. That's not the capacitor side. The capacitor, where is that? Where's the last capacitor? Where is the last? Come on. Where's that last capacitor hiding in there? Well, maybe that's the last capacitor. I mean, I got them counted wrong. 1, 2, 3. And I look back at the schematic here. Not even the schematic. So this is this is the switch. Pretty tricky to look at. Some of these terminals are on the back side from here, from this view. You clearly see the ones on this side. Really drawn them, even though the copy isn't the greatest. So what are we seeing here? So C5 was the one that I was suspicious of. It shows it located over here. Oh, what's happening to the wire? I don't know what's happening in here. They're having trouble drawing all this stuff, making it apparent. This is C12. See a little piece. It looks like there was a hole punched in the diagram when they copied it. There was a hole here. Maybe this is a folded page, and I don't know. Why would there be a hole punched in it here? That's not helping. This wire appears to come straight here. This one must be this wire. very hard to follow. But I think it's going up and over here. Boy, just about impossible to sort this out with this diagram. C14. You know, I looked for this capacitor a couple of times and couldn't find it. C14 to ground. I could not find it. It would appear to be C14. Let's look at the schematic. C14 doesn't sound like the right number. Okay, now I'm going to switch my head all around. Yeah, 14. This is nowhere near 14. 14. Where's C14? There's 13. Here's 14. 4.7. I believe that's really what that says. 4.7. Oh. Oh, so this is the other side of the same switch. Oh, okay. I really haven't traced this part. This is the part my buddy was telling me about. He looked at it, but I haven't yet. So let's see. So this is the cathode. What can we find out from here? Cathode comes down. Now I did test this last night to ensure a ground was in position no matter where the band switch was put. Is that what really is going on here? So go up this way, capacitor in the way. We come down this way, go through the switch. No, capacitor in the way. Here's the L19. So the cathode is grounded through L19 when the radio's in broadcast position. So they have an arrow here telling you which way it's going. You gotta assume these are going the same way. It must be, because here's a contact. Wait a minute. What are they doing here? And they show these contacts as long bars, but they show these contacts as dots. Why are you doing that? Why don't you just draw all this stuff over here as a bunch of dots? Go down here again. So in broadcast position, cathode is fed through this coil to ground. We snap the switch, assuming it's got to go this way. It can't go the other way. So we snap the switch. This is disconnected now for good. Is this making a connection to here? Well, it must be. The cathode has to be hooked up to something. So, okay, so this connects it to what? But so is this always? Well, it was always there. They would use a wire. They wouldn't feed it through a switch. What's going on here? So snap. Oh, well, I don't know. Maybe if you snap this up, this guy now contacts here, and this one contacts here. So these are connected. And this is all, L19 is no longer in the picture. So L19 is just part of the broadcast band deal. Okay, so we snap it up one. Now these two are connected. And it stays that way. 1, 2, 3, 4. There's 5 positions on this switch. So 1, 2, 3. What? The last position's connected to nothing. What's going on there? That doesn't make sense, does it? So, boy, these switches, they just, and all these radios have these complicated switches. And they're all custom for the radio. And trying to understand what they're supposed to do, really, I find that a really big challenge all the time. In fact, I stay away from it as much as possible because I've only got so much coffee. It's just burning the caffeine up left and right here looking at this. Okay, so once again, we're in the broadcast, right? Shown in broadcast position. Broadcast cathode through the coil, snap at one. This is out of the picture, according to the way they've shown this. But this guy, so maybe they're showing a long thing here to suggest that this does make contact. I mean, that's what they're trying to indicate here. And then up here, they had to do this. They didn't have to do this. They could have shown all these, like, see these little circles? There's something more here that I'm not getting about how this is working. There's probably a lot more. Not something. There's probably some things. Okay, next, so we're going, let's go again. Next band. We have at least this contacting that. Who could say that's not the case? And the cathode has to go somewhere, so it must be contacting here. So it's going through here, through here, through here, and it's finding ground there. Ground through this coil. And we go another snap, and this long one is here now. The short one is here. Still connected together, nothing else connected. Well, they just forget to draw one arrow on here? You know. 1, 2, 3, 4, and 5. 1, 2, 3, 4. So what would happen at the last? Well, there's the problem. They got a switch missing. Switch has no link. But if that were the case, then the cathode would be disconnected on the highest band only. And of course, that's stupid. That's just ridiculous. That's a ridiculous notion. So what are they trying to show here? Well, what am I not getting? For this guy to make it all the way up to here, he has to go 1 snap, 2 snap, 3 snap. The 4th snap, he's up here all by himself. 4th snap, wait a minute, it's not even 4. What the heck? So what's going on here exactly? He says, repeating to himself, because here we, in the broadcast mode, this is selecting this coil, and this guy's energized with the cathode current. So this is essentially going up to the grid. So there you have cathode to grid through the resonant circuit, capacitors and coils. And one more step. That was the sound of the switch there. Now these two are connected together, so the cathode feed is through here to ground. Oh, that's interesting. Here to ground. And this switch will have moved one up. We have the capacitor here and the coil there. The trimmer here and the coil there. And this way over here is the tuning capacitor. He's got to be in the picture all the time. So on broadcast, this, what they are pictorially showing as large plates, are operating. Snap it up one more snap. Now you've engaged this coil and this part of the capacitor, and this guy is in the circuit. So he's in the circuit. And so is this. Deep breath. These are fixed capacitors up here. Sometimes I get in my head that these are all variable capacitors, because for a while I thought this symbol was symbolizing the type of capacitor. There's a 2D looking weird capacitor in this radio, adjustable capacitors, but that's not these. These are all the fixed ones. I just have, sort of like previous ideas keep kind of welling up, and they're not, I don't want them to well up. I want them to stay in the bottom of the well. Okay, so thinking hard again. We're up here, connected here, cathode's grounded through here, cathode current causing an effect in this coil. The effect in this coil is working against this capacitor. There's some resonance, and then it's got a head to the grid. But by now this has moved up one. So now this is connected to this, which is connected to the grid. So there we are. There's the complete circuit for that band. So you see a broadcast band, very special arrangement, and the second band, another very special arrangement. Okay, now we snap it up one more. Snap it up one more. These two remain connected. We're still firing, the cathode is still grounded through here. And this connection is still maintained. And this connection is still maintained. We're starting to add in more capacitance up here. So these are just adding, from here on up, it's just adding capacitance. But this one is switching in this wire. Okay, so now we go to the next band. Let's go to the top band because I'm getting lost here. Okay, we can't do it because we don't know what's happening here. So the top band position, we're selected this coil, all these capacitors, including this wire. So we're always connecting, we're always finding this wire. Always connected. Because regardless of what the switch is suggesting, it's got to be connected. And we can't open the cathode. Unless this is how it gets its ground. No, can't through a capacitor, can't do that. It's got to be a low resistance connection like the coil here. Okay, so in the top position now, all capacitors are connected. This is still happening. Could be finding ground for the cathode through this coil is just immaterial. It just doesn't matter. I don't know, you're going higher and higher in frequency. I think this coil will become more and more important as you go. Am I missing something? Yeah, probably am. Well, assuming that's the case, this is always grounded here. Then the grid circuit, which is really this stuff, and this is always connected. Once you advance, this coil too. Perhaps again it's immaterial at the higher frequency, although I just runs counter to what I would imagine. On the schematic, these are all positioned as if they're in line, but they're not. They're side by side. The only reason I say that is because you could imagine that somehow they're all designed to influence each other. These two certainly are. These two certainly are. Some self, sort of like a auto transformer thing happening here. Somehow the output of the tube has to make its way, the output on the powerful side of the tube, the plate side of the tube, has to make its way back to the grid to get the oscillation going. So we can see how it's done here. It's in this coil, this being the grid side. Yeah. And how it's done here, cathode current is fed through here. That's cathode current, plate current, pretty similar stuff. So that's how this coil gets its feedback, and it's tied to the grid through here when the switch is advanced. Let's connect down here. Go the next step along the way. How is the feedback achieved now? How is it achieved for these two? Output is on the plate side is always going through this coil, which is mounted on this coil. You're in the vicinity of these two, but not really close. They're really close here. And this is tunable. Can't imagine this coil is the feedback for these two. So how does the plate signal get back to these two? This one works. This one doesn't. This one doesn't. So I must be missing something here. This screen is interesting. Let's look at the screen here. The screen can act like a plate, it can act like a grid, depends what you're doing with it. Maybe they're doing something with that. Yeah, this, I said the plate current always flows through here. And the screen is kind of tied in a bit. So become dependent upon the screen at that point. Somehow. So the screen is always tied here. Has a plate voltage effect being placed on it. So what I mean by that is the plate is oscillating like crazy, which it's supposed to. Some of that oscillation ends up on the screen. Deep breath, yeah. Designers do funny things with the screen. They even do funny things with the suppressor grid once in a while. This one's just sent to ground. Well, this capacitor is bad? What does that say there? C13. 400 volts at 0.005 is what I think it says. C13. Let's 0.005. I would very likely have changed this guy. Coming off the screen of the oscillator. 0.005. Let's look at this. So here's the oscillator. Did I say C13? Yeah, 0.005. Did I make a mistake on the size of this capacitor? C13. Maybe I did. 0.005. Okay, I'm going to check out that possibility. 0.005. And one of the things I'm terrible at is putting in the parts so the values are showing. That one looks like it's probably showing. I think it's this guy right here. Be attached to the screen. Let's just absolutely double check that. So that's a 6J5. 6J5. Oh, what screen? Wow, what am I doing wrong now? That's no 6J5. It's a 6J7. Oh my gosh. 6J7. Boy, I hope I didn't spend too much time looking at the wrong tube thing. I don't think so. 6J5, the screen is pin number 5. Is that right? No. 4. G2. Pin number 4. Pin number 4. Okay, I'm going to count in here. 1, 2, 3, 4. And there it is. There it is. This is the one that popped off the other day. Let's see if I can get a good close look at it. So again, ready for embarrassment, preparing myself mentally and emotionally for shocking embarrassment. $472K. 472K. Okay, I gotta figure out what that is. 472K. Yeah, they're pretty dumb about that way in which. Okay, so it's a .005. I'm gonna get one. Out of my tray here. Unfortunately, I have a bunch of them in this tray. Hey, there's no 5 there. .472. 602. Well, it sounds right. The 2 is right. Crazy situation. Can I measure that in there just to be sure? Just to be doubly, triply, quadruply sure. Yeah, I'm going to try and measure it here. Wow, I think the measurement's probably false because the capacitor's in the circuit. 73 microfarads. No, how about .00, whatever it was, microfarads. That didn't work. Okay, let me just look at a chart here for crying out loud. Such a simple question, you know, what's the value of the capacitor? It's .0047, which is .005, which is what is supposed to be there. That's not the source of the problem here. Oh my gosh. Something's got to be wrong with this radio. Ooh, it's taking a long time to set up this camera shop here. I ended up having to reboot my computer and everything. So this is the back side of the same switch. This is the cathode switching side of the switch. So this yellow wire, you can barely see some yellow here. That little bit of yellow right in there, right there. That wire goes down to the cathode of the oscillator tube. So let's just take a little bit of a longer look at it. Quite a longer look. So that's the yellow wire down in there. This capacitor is in series through this wire to a terminal on this tube. This is the actual oscillator injection point into the mixer tube. And also there's a resistor here, goes to ground. It's supposed to be 33K according to the schematic. Was 42 when I measured it. I replaced it with a 31. Okay, I don't think that's part of the problem. So what I want to do is examine the switch operation. We'll look again on the schematic, and then we'll look at the actual switch and see if I can't figure something out. Okay, so this is the back side of the switch we're looking at. This is the cathode yellow wire here coming. And up here you can see the capacitor that I pointed out, the 33K resistor, and up to the screen. Oh, it's my mother-in-law. Okay, so So when we look at the switch, this is the yellow wire coming up. This connection here is actually made up at the switch. Then we should see a contact in the broadcast position sitting here. As I advance the switch, we should see this come along, this come along. You know, again, why is this showing out like this? Why isn't this showing right here with a short post? And it was done that way here. Oh man. It has to be connecting these two. Cathode's got to go somewhere. Does it? Yeah. Yeah, there's no way. There's a capacitor here. There's no way for the cathode to get back to ground that way. It's getting its ground through here. Through here. Okay, so we know where the yellow wire is. I know which terminal this is. There's only one other terminal involved here. It's only one other terminal and some kind of wire going down to a coil. We should see a coil attached to this terminal. That's the only... Oh no, what am I saying? There's this terminal. Well, that one has this capacitor on it. This capacitor I've never found in the radio. Not sure why, but... Okay, so 3 terminals involved. 1 shown as a dot, 2 shown as... yeah, the arrows are on the moving parts. I started thinking, well, maybe these are moving. No, the arrows would be the moving parts, the sliding contacts here. Okay, well, let's look back at the radio. The yellow thing, next to it is another terminal with a wire going to a coil, and on the other side, I don't know what to say about that. You know, sometimes this might represent a... I don't know. Yeah, it might. Who knows? I don't know. Back we go. So I can feel a level of frustration building in me, and I know I cannot continue once I get into that frame of mind. Once the curiosity disappears and the whole thing starts becoming laborious, it's time to stop. So let's just go through this a little bit, though. I'll flip to the other camera. Okay. The yellow wire. 2 things on either side. So I can see one going to a coil right here. .49 meter band. You can see what I wrote on it. Okay, so the switch is in the broadcast band position. If I snap it once, so this finger here looks longer than the rest. No, I think I'm imagining that. So there's an inner ring. Looks like 2 of them are riding on the inner ring. Always connected together. Oh, what's this thing doing out here? What's this piece? This piece right here. What's it connecting to? There. The last position. Oh, I'm sorry. I got it backwards. This is broadcast. Okay, I'm self-confused. That's broadcast. So that is the little dot. That's the little dot. And the other ones remain connected all the time. Why are they even on a switch? That's it. what's going on there. Well, that last position, the first clip is no longer connected to anything. So in this position, the center and the far one are connected. Now the center and the close one are connected, and so it remains. So we have one position that does that. That's the broadcast position. The rest of the time, those two are connected. Well, that's exactly what the switch is showing, except it's one position short. That's a bad word to use. One position missing. Am I counting this wrong? That's one position, two position, three position, four, five position. And there's no more. So I guess the diagram is wrong. They should have had one more arrow on there. Once again, so broadcast, and then everything else after that. I'm really looking this thing over really closely. So the radio works in this position, works here, works here, doesn't work here, doesn't work there. Now those switches not making contact at that point. That's easy to test. Put an ohm meter between those two leads and rotate the switch. Starting here, it's open. The two I'm talking about, the two close ones here, these two. Maybe they're losing contact or something. So okay, so we're gonna ohmerize that. Ohmerize. Okay, so one would be connected to here. One lead to my voltmeter. The other, quickly please. The other, I got enough light going in here. Cut it back a little bit. The other goes basically to the cathode. I can actually connect way down here, which is actually a better way of testing it. Okay, we should see open circuit here. We see a 0. Okay, let's go back to 0. How do we get a 0 there? Always a 0. I thought this contact's out of contact. Isn't the contact out of contact? And I connected up wrong? Oh, I think I did. I'm on the wrong coil here. Wait a minute. I'm clearly on the wrong coil. Not so clearly. No, these two things are not connected. There's a space. I am on the right coil. Always a ground. Maybe we're onto something here. And I want to be on the yellow wire. And I'm looking. Definitely on the yellow wire. Got a 0 on the meter. My meter messed up. I didn't really check my meter properly. Oh, I think my meter was messed up. Whoop. Okay, what exactly is going on here? say 0 on just about every scale if it's a 0. Jeepers. 2.8. Work the switch. Okay. We're getting somewhere now. So this is what I expected, wasn't it? Something in 4 positions and something different in the 5th. Yeah, it could be like a back pass for my ohmmeter to utilize. So in this position, broadcast, this coil is not connected. Oh, then we go one step. That coil is brought into it. It stays in it. What's going on there? I don't remember that in the schematic. So basically, it's one way in one position, another way for the remainder. Wait, what happened here? I didn't go all the way. So it's one way. This is broadcast. And then the other way in all the rest of the positions. Why aren't we getting a 0? This should be a 0. Well, maybe that is a 0. Let's check. Best way to check without disturbing things too much. Pull this guy off. Stick them up here. So today 0 is, looks like 0.5. Well, that's suggesting here nothing's wrong with the switch. It looks okay. It seems to work okay. Why the maintenance of the connection to the 49 meter band coil? Why? What's going on there? What I'm saying is, in this position, this connection is made. And when we advance the switch once away from broadcast band, this connection is maintained. And that's what I was checking with the ohmmeter. It's always connected to this coil. The cathode is always finding its ground through here, except in the broadcast position. There's nothing else to it. It's just one way or the other way. There's no third way. This coil be open? No. Would it? No. Why? I should set the switch in broadcast position and check the resistance of this to ground. It would really strike me that I can't say I've ever actually picked anything up. This first snap would be the 6 megahertz band. Oh my gosh, you really got to look up here at the same time. So you go one snap. Well, this guy's brought in and always brought in. And this is part of the grid circuit. The cathode through this coil, through the switch thing down here into the grid. The cathode hooked up almost right to the grid. There's a ground thing happening here. Holy smokes! Why won't you work? Okay, so we've got to verify that there's something funny not going on here. Something funny not going on. Yeah, that's a tough one. What's the resistance of this? We should find the coil resistance. They've written it right there, I believe. They have the coil resistances written in here. They're very, very low. And it's written here. It probably applies to the whole thing. as a way of measuring the whole thing. It's fairly easy, I think. Take that back. The radio appears to work though in the first two bands, so how could any of this be bad? The resistance may be so low, might as well just see this as a ground terminal here. A solidly grounded terminal. I don't know. Measure it. Let's just measure it. Okay, last thing happening here. So this is the resistance I'm reading now through that coil. It should always be that. It should be the resistance of the coil. It should be a point less than that, but my meter, above my meter. I throw the switch. A little something happened there. Not much. Doesn't go open. The coil's not open. Holy smokes. Okay, I'm done for today. So I'm aware that these videos are pretty painful to watch, I would think. Depends how crazy you are. But I thank you very much if you are watching them. And keep hope alive. That's what I'm trying to do here. I can only do this for another day or two on this radio, then I'm going to have to switch to another radio. And this one's going to have to go away again. Hopefully, last time I put this radio aside for a week turned into a year. And most of the stuff in my head just drained out during that year. So I'm a little worried about that happening too. But I really thought I was onto something today. So anyway, thanks a lot for watching.